Hello students, welcome to my YouTube channel. So today I am going to solve the composite bar solutions. Before this video already we given the concept how to solve this. So composite bars means two or more bars will connected rigidly fixed with each other and central we have axial load. So this two bar length will be equal for bar 1, bar 2. So what is the given here? Middle the given steel rod. This dia is 3 centimeter. Then hollow copper rod tube the given. Hollow copper tube. How much? External dia will be 5 centimeter. Internal dia will be 4 centimeter. They are asking. What they are asking? Or read the first problem. A steel rod of 3 centimeter dia. So middle 3 centimeter dia is enclosed with the copper. Centrally is a hollow copper tube. So this enclosed by the copper tube. What is the external dia? 5 centimeter. Internal dia will be the 4 centimeter. The composite bar is subjected to an axial load or axial pull is 4,000. So 45,000. Okay, 45,000 Newton. If the length of the each bar is equal to 15 centimeter. So length always, because these are rigidly fixed. So this length always they may give equal only. So 15 centimeter. What they are asking? Stresses in the rod and tubes. So stress for the steel rod and stress for the copper tube they are asking. And load carried by the each bar. Each bar means steel rod and copper tube load we have to find out. So Young modulus they given. Young modulus for copper they given 1.1 into 10 power 5 Newton per mm square, and steel bar also they given Young modulus. So theorem I given theorem what they are telling now. Two case will be there. Case 1 na strain 1 will be equal to strain 2. Second one will be total force equal to P1 plus P2. These two concepts if we will apply we can solve these questions. So okay. So strain will be equal to the one steel rod. Then total elongations will equal to the hollow copper tube. Force 45,000 will equal to both share P1 and P2. So these two cases we can solve. So for this what you have to find out? Area required. No? So what is the area first? Area of the steel rod. Area of the steel rod. Pi by 4 because this circular section pi by 4 3 whole square. So this will be the area of this. How much this calculations we'll see here. So one more things we'll see. What is the given Young modulus? Mm square. So then this will make it the mm. So what will be this? 3 centimeter will become 30 mm. 4 centimeter becomes 40 mm. And 5 centimeter becomes 50 mm. Because 1 centimeter is equal to 10 mm. So we'll convert this mm. If you want to keep centimeter, then you have to change these two. So where will the easy work that only will do. So here what we'll write now? 30 whole square. So this will be the area already we calculated. So how much area is coming for pi by 4 30 square? Area is coming 706.86. 706.86 mm square. So area of the steel rod we know now. Area of the steel rod we know the. Now area of the copper tube. Area of the copper tube. So this is hollow sections. Hollow sections na pi by 4 you take common. Then outer minus inner. Outer how much there? 50. So we can write here pi by 4 50 square minus 40 square. 40 square. So pi by 4 d square. So hollow is there na external minus internal. So this how much value we are getting? Pi by 4 na. This also getting 706.86 mm square. So this also we are getting equal. So 706.86 mm square is not always equal, but now in this case both cases we are getting the equal area. Okay, area we got. Now you see this case 1. Case 1, strain will be equal to the strain of the copper tube equal to strain of the steel rod. So strain is equal to, see here, we know the Young modulus is equal to stress by strain. So strain equal to what we can write? Young modulus, stress by Young modulus. So we can write here stress by, what is this one? E value, E1, then equal to stress 2 by E2. So then what we'll do here? We'll substitute the value here. You write here E1 how much? So you can write sigma 1, in place of sigma 1 you write sigma is still S, sigma copper you write, that will be better, sigma copper. So strain of the steel equal to strain of the copper, like this you can write now, it will be better. Okay, so now sigma steel is equal to what we can write here? E1 by E2, sigma copper. So E1 how much? E1 by E1. You write this also, steel by copper. Steel by copper. So if sigma S is equal to steel will go top, steel by copper. So steel value how much? 2.1 into 10 power 5 divided by 1.1 into 10 power 5 sigma copper. This will be there. So this if will solve now, how much getting here relations will get? Sigma steel is equal to some relations will get. So I calculated, we'll check this value, 1.909, 1.909 it will come if you divide, 1.909 stress copper. These relations we got, give the equations number 1. So case 1 we did. Now we'll go the case 2. What is? P is equal to P1 plus P2. Total tensile force equal to copper tube force plus steel rod force. So problems I will rub it now. All the data we taken. So okay. So now you see how we'll solve this. Now case 2. P equal to P1 plus P2. So what is P they given here? 4,500, because 45,000 equal to P1. So see here, stress equal to force per unit area. Then P1 equal to stress. So P1 you give here P steel, P copper. P steel, P copper, right? That will be better, no? Or that only we are assuming. P steel. So steel, if will P steel area. So what will be there here? PS equal to AS plus sigma copper into A copper. So okay. So now sigma S equal to how much we can write here? This will carry here 4,000 equal to 30 na. Sigma S 1.909 Cu into AS. AS we calculated steel area of the copper. So how much? 706.86 plus sigma copper, that means stress of the copper ACU will be same value 6.86. So here what will get? This will be sigma copper. So sigma copper you will get in this formula. So if you will substitute all those things, what will get? So value we have. So it will get 21.88 Newton per mm square. 21.88 Newton per mm square. So stress of the each bar they're asking. So stress of the copper tube I know. Now what we'll do, substitute this give equations to, substitute equations to in equation 1. So what is equation 1? Stress of the steel is equal to 1.909 into 21.88. So this value will come stress of the steel rod. Steel rod value will be 41.77. 41.77 Newton per mm square. So first what they're asking is stresses of the each bar we know now. Now what they're asking, each load they're asking now. So okay, now we'll calculate here second part, load. So where this relations is there, load. So now you know stress of the steel is equal to, stress equal to what will be there, P by see this, stress equal to load by area, load steel by load area. So what they're asking, PS. So how you can get PS is equal to sigma S into AS. Sigma S into AS will calculate. So what is the sigma S? Already value we know, 41.77. So we'll write here. Space okay. 41.77 into 706.86. So this is the pressure of the steel rod. So how much this calculations will be there for us? PSAS na. So this calculations is coming 29525. 295 big value. 29525. 29525. 29525. 295.5 Newton. 0.5 Newton. So we got the pressure of the steel rod. Now similarly we will get the pressure of the copper rod. So if 40, this one 45000 minus this if you will do na, you will get the answer for the copper rod. So where we'll write this? Okay, here I'll write this final answer. What is? Suppose they're asking pressure of the copper. So either you calculate stress into a copper, or total how much we know, minus 1 2 3 4 5 295 to 5.5. So this how much subtractions is coming? 15474 0.5 Newton. 0.5 Newton. So what you are getting here? Answer. They are asking stress in the, this will be the answer. Stress in the copper tube, stresses in the steel tube, pressure in the steel tube, steel rod, and copper tube pressure. So this is your answer here. So these two they are asking here. So composite for problems now, two relations only you have to follow. First relation is strain will be equal, then second will be case pressure of the total pressure equal to pressure of the given bar. Here steel rod is there, pressure of the steel rod and pressure of the copper tube. So these two if you will compare, you will get the answer. So okay, so this method like you have to follow and you have to solve these questions. Okay students, watch the video, subscribe the channel, share this video to your friends. Okay, thank you.